Good morning, everyone. Morning. Can you hear me?
Yes, we can hear you.
All right, thank you. We wait for a few more minutes, maybe 8:05.
Okay.
Okay, so it's 8:05. So before we start, I just would like to highlight that I set up this Google Classroom where you can see the previous session recording and as well as the previous session's slides. So earlier last year, mid last year, we sort of line up what we're going to discuss for the stat session for the PITS department. So basically, we have covered session 1, 2, and 3. Now, for today's session, I decided to combine session 4 and 5 so that it's a bit more cohesive. Yeah, so you can join this Google Classroom. At the end of the session, I will upload the session for today's slide and recording as well. Yeah, I'm gonna give you the code to join this one as well if you haven't joined already. So today, as I mentioned, we're gonna discuss about descriptive statistics and data distribution. So today, basically, we're gonna focus on descriptive statistic and the type of data distribution, and also why it is important. And we're gonna see how to perform these statistics in the SPSS. So before we start looking into our topic today, just would like to give another reminder of sort of a non-chaotic steps for your thesis journey, I would say. So first of all, before you want to recruit, you have to identify your variables based on your study objectives, and then you have, I think this is optional, but I think it's good to do, good practice as well. So you prepare an empty SPSS data sheet with all the planned variables based on the objectives, even before you collect your sample. Then after you have prepared your SPSS sheet, since during your proposal you will already have your data collection sheet, so you can translate it into SPSS straight away. Then it will be easier later on. Then you can anticipate if there's any problem with your data. So next step is to collect your pilot samples, and then after a few runs of recruitment, I would say this depends on your total expected number of recruitment. So if you have like 100, then maybe 10% is good enough. So after you have recruited around 10% of your expected sample pool, then you can try to input and analyze your sort of your pilot sample. So this 10% we consider as a pilot sample. Then after you have some prelim analysis, you expect, or probably, this parameter you want to make it. For example, before this you just record. For example, if you're doing some cancer studies, before this in your recruitment sheet you just say, oh, this person, whether the patient that you have recruited have received, for example, anthracycline or not. Then when you go along, you decided maybe you want the dose as well. So then with the help of your pilot sample, when you do your prelim analysis, you may sort of gauge whether do you need a dose, or is enough for you to have a yes or no for your anthracycline. This is just one example. And then if you sort of like solidify your list of parameters and type of data that you wanted to get, then you can continue sampling until the end. And at the end of the sampling, you can do some, this is a must, this is not optional, you have to clean your data properly. From the previous session, I already mentioned that type of data, you're going to have continuous data, you're going to have categorical data. So you have to assign the type of data correctly in the SPSS. If not, your analysis won't be done in a correct manner, I would say. Then you can start to analyze. Only then you can have sort of a pleasant journey towards the end of your thesis writing, including your stats analysis. If you were at the end and then suddenly you decided, oh, I missed out some things, or you decided to, now you want to take the dose instead of the just yes or no, then you have some trouble at the end. So to prevent that, I would recommend you to have some pilot analysis first, just to confirm that what you have planned, the parameters that you have planned earlier, still applicable to your study and can answer your objective. That is the main thing. You have to have a list of parameters that can answer your objective. Okay, so we're gonna go for the first part, which is the descriptive statistics. Of course, this descriptive statistic, I think most of you will know. Probably not the name descriptive statistic, but it's actually it's a summary. It's basically a summary in order to describe the characteristic of the data. So basically, two types of descriptive statistics available, which is central tendency and measure of dispersion. So both needed, I would say, to describe your nature of your data. So what is descriptive statistic basically? As I said, the central tendency is actually mean, median, and mode. So as the name implies, central tendency. So it's your most of your data will tends to cluster at the middle point, where is the central located. So we usually want to report the central tendency, which is the central point. How do we do that? Is by reporting the mean or median or mode in some cases. But most of you, I think not many of you will need to use mode. So I would say 90% of the time you only use mean or median. So again, the use is to indicate a single average value to represent your data. So sort of the reader, the evaluator, the reviewer, your reader basically can sort of appreciate the the general overview of your data. So next we also have a measures of dispersion. So basically this is to indicate the spread of the data. So most typical would be range, interquartile range, and standard deviation. Variance is a bit not too common, I would say. So basically the three, range, interquartile range, and standard deviation. So these are the most common descriptive statistics that you will likely to encounter and need to report later on. So later on, we're going to discuss on which one to select. So this is some definitions just to revise. This is like, I think it was probably primary school. I mean, probably primary school. Yeah, so this is just to just a short reminder. So mean is the arithmetic average of all values. Median is the central value of the data points when arranged in ascending or descending order, basically a midpoint. Mean is average. Mode is the most frequently occurring values in the data set. Then for the spread, standard deviation represents the deviation of all the data points around the mean. So standard deviation is more applicable to the mean. Range basically is the gap between the highest and lowest value in the group. Basically, if you recruit, basically it most likely would be close to your inclusion criteria. For example, you say you want to recruit diabetic children aged 5 to 18 years old. So it's just the total number, total range. Basically, if you recruit 6 to 17, that is your range lah, basically. So interquartile range closely ties to the median usually. So it represents the gap between the mid 50% values when the data is arranged in ascending order. So the data usually will be divided into 4 quartiles, and we report the 25th to 75th quartiles. That is your interquartile range. So actually the interquartile range in SPSS, if you use a certain steps, you will get the interquartile size actually. So you only get one value for interquartile range. So this is not so accurate. I'll show later on how to get the actual range, which is you need have to have like two values, x to y, something like that. So we're going to go into that later on. So next, data distribution. So there are several data distribution that is available, but we're going to focus on these two types of data distribution, which is the normal and not normal, or usually known as skewed. So there's various types of other distribution, but I think most likely you only encounter these two, and it is the one that you have to look at whether your projects or your studies data fall under either of these two or not. Why? Because in order to select the most suitable descriptive statistic, for example, whether you want to choose mean or median, you have to know the data distribution. So if it's skewed, then you're going to take median, and if it's normal, you're going to take mean. So yeah, this is just to show the effects of skewness on descriptive statistics. So if you have a fairly symmetric distribution, you're going to have your mean, median, and mode almost having the same value at a midpoint. Whereas if you have a skewed distribution, your mean, median, and mode may likely to be a different value. It's a bit dispersed. So mean is very sensitive towards a skewed population. So whenever you have a skewed, not normal, asymmetric population, if you report mean, it's not the most accurate measures to report the central tendency, as it's lying at the slope rather than near the middle. So that's why we prefer median compared to the mean in a skewed distribution. So mode is always at the peak, but most of the time mode is not too useful in our setting, but in certain project or cases, then you may want to report mode as well. But just to highlight that median versus mean, in skewed distribution, you have to select median. So again, just to highlight, mean usually couple with SD, median we couple with IQR. So these two is together when you want to report them. So usually it will be more towards your table 1. You want to report the demographics, you want to report your overall biochemical parameters, things like that. So as I mentioned, probably your most typical goal for descriptive statistics is table 1. Regardless of your study, whether it's going very in-depth or not, probably your table 1 going to be demographics, an overview of your overall data. So some study would have the entire thesis or the entire study is just descriptive studies. So probably you're going to have multiple table that will use or utilize the descriptive statistics. But for some of you that have a bit more complicated study, you may have your table 1 as study demographic and characteristic, then you still want to use this descriptive statistic, and then probably for you that have more complicated study, you may have some other things like compare the mean, compare the median, have a logistic regression and whatnot. So most probably this table 1 is the same for everyone. So next we're just going to try to do, I'm just going to show to you how to do it in SPSS. So in this lecture slide, I already have steps by steps, but we're going to do a live demo. So I'm going to use a sample data, which is a real life data, which is this is a study under Prof. Hani. It's a cross-sectional study to see the telomere length of a childhood cancer survivors versus the controls. So again, the goal is we want to get the table 1, which is the characteristic, the overview of the population. So we're going to try to fill up this table accordingly. So typically we're going to have either mean, median, or the number and the percentage for the categorical variables. Okay, so I prepared the step by step, but we're gonna skip this step by step. But I'm gonna show you a live demo. Later on, you can refer to this slide for you if you want to follow step by step. Okay, I have the data set open. So basically, this is the data set for the child cancer survivors. We have 100 here, just to show. Yeah, we have 100 entries. Around 1-to-1 ratio of survivors against controls. So first, if you want to get for example, the gender first. So you want to get the overview of the gender, analyze descriptive statistics, and then you press cross tabs. Yeah, so basically, you're gonna put in your group. So in this case, the group is 1 is CCS, child cancer survivors, 0 is controls. So you can put either row or column. It doesn't matter. But you want to, I think you may try to follow your intended table. For example, your table just now, the column is the group, then you try to follow suit. So it's a bit easier to follow the output later on. So column is the group. And then for your rows, it's gonna be gender. In this case, I already recode the gender. 1 is male, 0 is female. Then this is just a by the way thing. If you want to get the chi-square, you're gonna press statistic and chi-square, but this will be covered in the next session. But just a quick remark. So if you want to get the percentage together with the count, you press cells, and then you can tick accordingly whichever you want to go. If row, basically it will total up the basically horizontal line is 100%. If column, then vertical line is 100%. So in this case, probably you want a column instead. So we'll see the difference if you go either way. So then you can press OK, and this will be your output. So basically, again, I apologize, I forgot to label this. 1 is male, 0 is female. So basically, for controls group, you have 28 versus 20, female and male. So as I mentioned just now, we tick the percentage according to column. So the 100% is vertical. So basically 58.3% plus 51.7% is equals to 100%. So basically it's vertical. So you want to say within controls, how many percent is female, how many percent is male. So you can go either way. This depends on your nature of your data, but you just have to take note which orientation of your percentage that you want to select. So you can, based on this, you can fill up the data. Yeah, as such. So you can fill up the data, your table. Sorry, fill up the data into your table. Fill up the data into your table. Then we're gonna try to do for the next one, which is the age and so on. But just now it was a categorical variables, so it's fine. But if it's continuous variable, you would want to confirm that your variable has been assigned with correct measure. So this is what I mean. For example, age is a continuous data. You should have scale as your measure. And just now it was gender, so it's correct to assign a nominal. So the option is scale, ordinal, nominal. So again, we want to look at age, scale, correct. Then you want to look at height, scale, correct. Weight, BMI, all scale. So it's properly assigned. Then only you can do the descriptive statistic, and this, then the data distribution. If not, you won't get a correct output. So basically, how to do so is you click analyze and then you click explore. and then you're gonna click the group. So basically, because this study have 2 groups, this is entirely optional. You can not put any group at all. So for example, if you are having a cohort study, you just want to recruit, for example, a pool of autistic children. So you may not have a group, which is fine. You just put in your dependent. So just to show, so we put an age, and then height, weight, and BMI. So we put it here. So if you have no grouping, then you can just let it be empty. But if you have group, like this one, you can put group here. Okay, so to proceed, press the stick nothing here. So plots. So if you check this normality plots with test, this is when you will get the the distribution, data distribution analysis. You want to see whether your data is normally distributed or not, is by checking this option. Then you press continue, press option. This I already put in into the slide the notes about what does this means. So I think I'll mention briefly, but you can refer in the notes later on. So basically, if you press exclude cases list-wise, what the SPSS will do is basically will include the most complete data. For example, you have 50, let's say you have you have recruited 100 patients. For your age, you have a complete, everyone will have, and you have successfully gathered all the age of your patients. But then, for example, for height, for example, 3 of your patients, for some reason, you miss the height. So you only have 97 patients with complete data. Means every single parameters that you want to analyze, you have the data. So the maximum number of complete sample is 97. You get what I mean? Even though you recruit 100, only 97 will have everything completed. So if you choose this one, the SPSS only will take 97, those 97 that are complete. If you take this one, it will analyze the 100 for age and others, but only 97 for the height, because you have 3 missing there. So this again depends on your fullness of your data collection. So just a note there. Then make sure you press both. If you just pick either, then your normality analysis may not be appearing. So click both and OK. And then the output. So yeah, just again, I choose the second option just now. So for age, I have sort of more complete data for all 100 population. But then for my height, weight, and BMI, only have 40 completed. Just haven't typed in yet. So it will just only will analyze those 40. And then this is why so basically when you choose the second option, you will analyze the maximum. So you have here mean, median, mean, median,
Shafiq, sorry to interrupt, your audio has gone off.
Okay. Somehow it's just muted. Thank you, Dr. Subah. So, okay, again, basically Kolmogorov-Smirnov and Shapiro-Wilk is both acceptable statistic for testing the normality. Shapiro-Wilk is more sensitive than Kolmogorov-Smirnov, especially when you have smaller sample size. So if you sample size less than 50, you may want to go for Shapiro-Wilk rather than Kolmogorov-Smirnov. So the column that you want to look is the significant column. Basically, if you have significant value less than 0.05, you will indicate that your population, the distribution of your data is not normal, it's skewed. So basically for age, significant means my age is skewed. For my height, it's normal. For weight, there's two options here. So for the controls, they are skewed. For the survivors, they are normal. So in this case, I would say take the, how to say, if positive and negative, you want to you become negative, right? Positive times negative become negative. So it's sort of like that. So you're gonna take it as, for the weight, you're gonna take it as skewed. It is okay to report median for normal data in this case because as I mentioned earlier, if it's a normal distribution, your median and mean is likely to be very close together. So if one is skewed, we're going to treat both as skewed for the weight. So for BMI, it's normal again. So once we have gathered this data, we know the nature of your data, then you can select properly. For age, because it's skewed, you're going to take the median and IQR. For height, you're going to take mean and SD. So as I mentioned, mean and SD is here. You can take straight away. Median as well, but not the interquartile range. Interquartile range, this one is not accurate. So how to do so? Before that, we go to the slide again. This is just the step. You may want to read later. Okay, this is the summary again. I've put it here, the note. Okay, so how to get the actual IQR? So basically, there's two steps for you to do this. Either you want to check the median IQR one group at a time if you have more than one group. So for example, here I have two groups. So I can select the first group, which is the control, for example, and then check the median and IQR. And then after I get for the controls, I'm going to select the survivors group, and then I'm going to check median and IQR. That's one option. Another option is you split the file. What happened is when you do this option, you're going to analyze both groups simultaneously. So I'm going to show you briefly. So, okay, so you go to data, select cases. This is the way that you want to do one by one. So if condition is satisfied, you press if. So in my case, my grouping parameter is called group. So I bring it here. So for example, I want to do for controls first, group. After I bring it here, press equal here, and then press 0 because 0 is denoting the control group for my case. So you press OK. Then what happened is, if you see here, group 0 will be selected, but group 1, which is the survivors, have this cross. What does it mean? Is basically this CCS or the survivor group will not be analyzed. So that's how you want to just analyze one population. This is also useful if you want to do subpopulation analysis. You don't have to copy paste your controls and then you just do for your controls, and then if you have the second group and third group, you don't have to copy paste and into a new data set. You can just do this instead. So next you're going to go to, after you have chosen your group, you go to descriptive and then frequencies. Put in the parameters that you want. So just now age is skewed, as well as the, I think was the height. No, height was normal. Weight, actually, weight is skewed. So weight. So you press the statistics, then press you can take mean, median, mode, everything from here as well. So in this case, we want median, and how to get the IQR is press the percentile. You put in 25, which denotes the 25th quartile, and then you add another one is 75th. As I mentioned, median is actually the mid 50% of the data. So you want the data range of 25th to 75th quartile, then you get the 50th, mid 50th, 50% of your data. So yeah, median and percentile. If you want to include mean and standard deviation, you can do so as well from here. So just press OK. Then you're gonna get the median here. So median is 24. It is identical to the previous steps, previous method using the explore. So for the IQR, you're gonna take, basically what you want to write is 22 dash 26.75. So this is your IQR. So once you have this, you can input in your table. So just quickly to show the other option is to use the split file. If you use before that, you're gonna cancel. So you want to cancel off the selection just now, just press all cases again. If you want to do for the second group, you just press this and change to your next group. For this instance, we're gonna select all cases to cancel out everything. You can see here, survivors has been included again. So you press data, split file, and then you want to say compare groups. So basically you put in your group, and then that's it. Yeah, that's it. So you press OK. Then you can do as just now. You go to descriptive, frequency, and then age and weight, and then press OK. Then what happened here is you have straight away two groups, control and survivors, their median and their interquartile range. So that's how to do it. Once you have get your output, you can fill in the blanks, basically. Yeah, so like this. So so what if in your one table you have several non-uniform type of data? For example, age is skewed, height is normal, and so on. So I would suggest that you report as it is. So basically, if age is skewed, you're going to report median. So you just have to denote it carefully. So for example, here, square bracket means it's median and IQR. And for the height, it's the normal bracket, SD. So your reader will know that which statistic that you will use. But I know for the purpose of publication and some streamlining of your data, you may opt for just take one type of statistics, I mean or median, across your whole table one, which is fine as well. But for me, I would go for the skewed. If you have at least 50% of your parameters are skewed, then you're gonna report all as skewed, which is you report median and IQR. So that will be more accurate rather than if it's skewed, report mean. It's not too accurate compared to when it's skewed, it's normal, you report median. So it's better that way. Yeah, so basically that's all for today. I'm going to upload this into the Google Classroom. This is the code if you want to download all the previous materials as well. Anything you can I guess contact me, then we can try to do together. Any questions?
Dr. Syakib, Asmah here.
Yes. Yes.
I want to ask for the test of normality.
Yes.
If the skewness is plus minus one, means it's normal data, right?
Again, come again.
If the skewness is within plus minus one,
Right.
does the data means it's a normal distribution data?
Yeah, yeah, sort of. So that is another way. So by looking at the skewness, but most likely we want to use either Shapiro-Wilk or Kolmogorov-Smirnov because that that have an objective value of significance. So if you use to the skewness, they have no, sort of the significance. So it may be affected by other factors. If you use Shapiro-Wilk and Kolmogorov-Smirnov, it's more safe.
I see. So if the skewness is looks normal, but the Shapiro Kolmogorov-Smirnov and Shapiro-Wilk is not normally distributed, so we follow that one.
Correct. You follow the Shapiro-Wilk and Kolmogorov-Smirnov.
Okay. The second question is the exclusion of the missing data.
Mm-hmm.
Can you show in a bit again how to exclude that one not to be in the percentage?
Not okay. Basically, you want to exclude or include?
To exclude.
To exclude
Yeah, that missing values.
the missing value. So, basically, if you're so okay, I'm gonna drag the again. So, if you have missing value, for example, um, let's go to the weight, I guess. Okay, for example here. So you can see, right, total cholesterol. Um, if your missing value is denoted as this dot, then the SPSS will not analyze it.
Okay.
So if you have for some you may put in as I know some of the statistician want to put in as 99999 to denote a missing
Correct.
value. Yeah, you can do that as well, but you have to remember to label it carefully. So in the value, you have to denote it carefully. Which one is the range of missing value? But for me, I like to just use it as a dot. So because dot, the SPSS will not treat it as a data, so it treat it as missing value.
Okay, okay.
Mhm. Any other questions? Okay, if
Shafiq,
yeah,
may I ask a question? So if you put the dot, then if we
yeah,
exclude cases pairwise, the SPSS will only analyze the ones where it's complete. But like for certain variables, we may have more n, right?
right,
More, right? Whereas
right,
for
right.
others, you'll have less. Is that how it works? Whereas listwise, it's only the complete variables that will be assessed.
Correct, correct. So,
Okay.
yeah, this I already prepared a note here. So, for example, here, if you exclude cases list-wise, then what happened is your SPSS will take the most complete, the only the complete data. You see here, even though I have actually 48 and 52 with age, but then because I take the list-wise, then SPSS will only take all 40 pairs rather than 48,
Oh,
52 for age. So that this is to show the effect.
okay.
So
Okay. Thank
as
you.
much as much as possible, you want to try to complete your data collection and everyone will have a complete data. Then you won't have to care about this. Yeah. So yeah. So if anyone have any other questions? Okay. I guess we're gonna end here. If you have any other question, you can always email me, WhatsApp me. Um, as usual. Thank you everyone for having me and listening. Thanks.
Okay, thank you, Shafiq.
Could I
Thank you.
so the MOs can talk to you on your Google Classroom?
Yes, they can. Yes, just join the Google Classroom. I can. I mean, if you ask here, then everyone can see the answer as well. So it's good for everyone. But if you just ask personally, then not many people will know the answer. So if you ask here, then it's good for everyone.
So the Google Classroom questions is a one-to-one, so nobody can read all the other questions that are asked.
It can be that way, but if your question is very general, then it will benefit everyone if you ask publicly.
Yeah, I'm just thinking some of the MOs have a project and so they have their data. Some are, we have MOs at different stages. So I'm just
Right. Yeah. So if you ask publicly, then everyone can see your question. But of course, if you ask personally, then I'll just treat it as confidential and everyone will not see anything.
So in Google Classroom, there's a way to ask personally or have it open. Is that correct?
Yes, correct. So if if it's like Facebook, you can see later. Yeah, so this is it. So you can just type anything, type any question regarding whatever you want to ask, then everyone can see. But if you want to make it personal, then because I log into my own account, then you can just message personally as well.
Okay, so anything that they type into the add class comment
Yep.
will be seen by everybody.
Correct.
Thank you.
All right. Thank you all.